In this illustration, we are going to find the degree of unsaturation of the given compounds from the molecular formula. Starting with the first problem, molecule is CO2. We have learned that oxygen does not affect the degree of unsaturation of a molecule. Therefore, we can just ignore it and make it CH0, since there are no equivalent hydrogen atoms present in this molecule. We know for one carbon with the number of hydrogen required is 4. Therefore, the change in number of hydrogen atoms is 4, making the du equal to 2. For the next problem, C15H10. For 15 carbons, we require 2n plus 2, means 2 times 15, that is 30 plus 2, 32 hydrogen atoms. Therefore, the difference in number of H atoms is 32 minus 10, that's 22, making the degree of unsaturation equals 22 upon 2, that's 11. For the third problem, again oxygen will not affect the degree of unsaturation of the molecule, so we can just neglect it, and the equivalent will be C16H12. For 6 carbon atoms, we require 14 hydrogen atoms, 2n plus 2. Therefore, the change in number of hydrogen atoms is 2. Therefore, the degree of unsaturation is 2 upon 2, that's 1. For the fourth case, halogen atom is equivalent of addition of one hydrogen in the molecule. Therefore, this bromine can be replaced by plus 1H. And this oxygen does not contribute to the overall molecular formula. Therefore, the equivalent compound is C13H10. Now, for 13 carbons, we require 2n, means 26 plus 2, 28 hydrogens, making the degree of unsaturation equal to the difference, that is 28 minus 10, that's 18, making the degree of unsaturation equals 18 upon 2, that's 9. For the fifth case, we have CX, as in the case of Buckminster fullerene C60. This X indicates the atomicity of carbon. We can assume it to be H0. For X carbons, the number of hydrogen required is 2x plus 2. Therefore, the change in number of hydrogen atoms is 2x plus 2 minus 0. Therefore, the degree of unsaturation is 2x plus 2 whole by 2, that's x plus 1. For the sixth case, the isotopic hydrogens, the hydrogen, deuterium and tritium, are treated as the same and will contribute to the same equivalent of hydrogen, making the formula as C3H3 plus 2 plus 1, that's 6, and N6. Now we clearly know that nitrogen is an equivalent of removal of one hydrogen from the molecule, making the formula equals C3H6, and this nitrogen is minus 6, so that becomes overall 0. Making this equal to 3 carbon, we require a total of 8 hydrogens. Therefore, the change in number of hydrogen atoms is 8. Therefore, the degree of unsaturation is 8 upon 2, that is 4. For the seventh case, again C star indicates carbon 14. Therefore, there is no difference in the degree of unsaturation of the molecule, making the formula equivalent to C6H12N4. And similarly, the equivalent for nitrogen is subtracting that number of nitrogens from hydrogen, making it C6H12 minus 4, that's 8. And for 6 carbons, we require 2n plus 2. 2 times 6 is 12 plus 2, 14 hydrogen. The change in number of hydrogen atoms is 6. Therefore, the du will be 6 by 2, that's 3. The answer. For the eighth problem, oxygen will not contribute any degree of unsaturation. Fluorine, being a halogen, will contribute to plus hydrogen. Bromine is also an halogen, it will contribute to plus hydrogen, and nitrogen will contribute to minus hydrogen. Therefore, the molecular formula becomes C12H10. We need to add 2 hydrogens for the fluorine, again add 2 hydrogens for the bromine, and subtract 2 hydrogens for the nitro. Net formula becomes C12H12, making the degree of saturation for C12 we require 24 plus 2, that's 26 hydrogens, making the degree of unsaturation equals 26 minus 12, that's 14, by 2, that's 7 is the correct answer to this problem. For the ninth case, we have C5H7NO2Bi. Again find the equivalent. We know that nitrogen is equivalent to minus hydrogen. Oxygen does not contribute to the degree of unsaturation. For the bromine atom, we have proved that it is also equivalent to minus 1 hydrogen, and for the iodine atom it is equivalent to addition of 1 halogen. Therefore it becomes C5H7 minus 1 for the nitrogen, minus 1 for the boron, and plus 1 for the iodine, making the formula to be C5H. 1 and 1 get cancels, H6. For 5 carbons we require a total of 12 hydrogens, making the degree of unsaturation equal to 12 minus 6, that's 6, by 2, 3. For this molecule we can assume there to be carbon 0. For nitrogen we know that it is equivalent of removal of 3 hydrogens. Therefore the molecular formula can overall be written as C0H, 1 hydrogen for the present, and minus 3. That becomes C0H minus 2. For 0 carbons, we require 2 H atoms, being 2n plus 2, 2 plus 2. Therefore, the change in number of hydrogen atoms is 4, making the degree of unsaturation equal to 4 by 2, that's 2. For the 11th case, we have B3N3H6. Again, finding the equivalent. B3 is equivalent to minus 3H. Nitrogen is equivalent to minus 3H, and hydrogen is equal to H6. Again, making the formula to be C0H0. We know that for C0, we require 2 hydrogens. Therefore, making the change in number of hydrogen atom be 2, therefore the degree of unsaturation of this molecule is 1. The last two results are being a bit absurd, can be verified by the structural properties. N3H is hydrazoic acid and its structure can be verified as follows. We can clearly see the presence of 2 pi bonds which verify the degree of unsaturation to be 2. And for the 11th case, we know that this is the case of inorganic benzene. The structure is as follows. It is BBBN, a cyclic structure it is, and with completing the valencies we find out that there is only one ring and no pi bonds, proving that 1 is the correct degree of unsaturation for the given molecule.